Here's where we left off on the first video with this question on page 3 of your notes that uses partial factoring. Now, we are not going to spend a whole bunch of time on this in class. This is an extra kind of topic that we can cover if we want. I'm going to show you here, and if you're interested in digging deeper into this, I would like you to do this as well as the questions in your assignment that relate to partial factoring. Some of you are ready for this and are up for the added challenge. So we're asked to factor this question that we cannot find two factors that multiply to negative 12 and add to negative 3. And so we need to use partial factoring. So we take the original function, and what we're going to do is just take a common factor out of the first two terms. In this case, it would be a negative x, and then we'll be left with an x plus 3, and then the plus 12. Keep in mind this is not the function we're using. That was a part B of the question. Okay, so we've partially factored it now, looking at the first two terms. And now we're going to take the two factors that we have. This negative x is being multiplied by x plus 3. Those are the two factors that we've found with the partial factoring. And we're going to set each factor. I'm just writing this so you have the notes for next time. Set each factor to equal 0. Okay, so we want negative x to equal 0, or we're going to say x plus 3 can equal 0. And then we want to solve that. So if we have a negative 1 multiplied by x here, we divide by negative 1 to solve it, and x will be 0. In this case, we subtract 3 from both sides to solve, and x is going to be negative 3. So remember that these are not the actual zeros, the actual factors on the x-axis that give us our answer. We're partial factoring, so we're given any two x-coordinates on the parabola. So in order to find the y-coordinate at this point, we need to put a 0 in for x. So we're going to have then into the function a negative 0, doesn't really matter, times 0 plus 3 plus 12, which equals 12. So from that we know that x will be 0 and the y will be 12 of that point. And secondly, if I can fit it in here, let's put the negative 3 into the function. And we'll have negative 3 times negative 3 plus 3, and that equals 0, plus 12. And we find there that 0 plus 12, this equals also positive 12. So we get the second point of negative 3 and 12. That is on the graph, and that's going to help us to draw it. Okay, let's sketch it out now. Remember that step 1 is factoring it, and step 2 is finding the detail. So I've written the function again right above step 2, looking at the details, so that we can see it right away. Is it concave up or down? Hopefully already you can be looking immediately at the coefficient of the x squared to know that if it's negative, it's concave down. Okay, the y-intercept happens at the c. So we see that y-intercept is going to happen at y equals positive 12. Okay, the axis of symmetry, this is the very middle line of it, and we know that the axis of symmetry happens at a plus r divided by 2. It's going to be right in the middle of these two. It happens at a. Now we'll use our partial factors, which was 0, plus r, which was negative 3, divided by 2. So we know that the axis of symmetry is happening at x equals negative 3 over 2. Now just the vertex. So we know that the vertex lies right on the axis of symmetry. So we know it's going to have this x-coordinate. We can write that in here already. The x-coordinate is going to be negative 3 over 2. and that's right in the center of these 2 points, right? So that makes sense. What we don't know is how high that vertex is going to be. Like, what's that y value of it? So let's put this x in to the function. And so it's going to be negative 3 over 2, that's the x, squared, minus 3 times 3 over 2, negative, plus 12. Okay. Now, fractions always look a little more daunting, but if we take our time, it's not a problem. Okay, so squaring a fraction means just multiplying it by itself. So negative 3 times negative 3 will be 9 over 2 times 2 is 4. That's the squared. And now negative 3 times negative 3 will be positive 9, and the denominator is 2. Okay, so we're on our way already. Negative 9 fourths plus, now in order to add this we need common denominator. So we want it out of 4, so we need to multiply the numerator by 2. Okay, and now let's make sure too that we're writing, actually I'm going to go back and write 12 as over 4. So we see that 48 over 4 is the same as 12. Okay, now if we add all those together, we get 57, positive 57 fourths, which is a 14 1/4 when I turn it into mixed fractions. Okay, let's draw this now, and there's no, okay, I think you'll have room on your page for step 3, the graph. Now, let's start with the vertex. Oh, we forgot to write this. The y-coordinate will be 14 1/2, or we can write 57 fourths for the y-coordinate. Okay, so negative on the x here, we've got negative 3 1/2. Sorry, 3 over 2, which is 1 1/2. Let's say about here. And then that is about 14 1/4. Now, we're not going to count up. It's not scale. We're just doing a sketch of it. So there's the vertex at the very top. We know this opens down, so it looks correct. These 2 spots, the partial factors that we found, can be plotted in. So 0 and 12 would be about here, and negative 3 and 12 would be about here. And that looks really good. Okay, so now we can do a rough sketch of that. And it should look like that. Now I'd like you to go ahead on Desmos and check it out. It's going to have zeros, these 2 spots, at decimal places, something that we couldn't factor easy with whole numbers. Okay, this is an example of writing equation from just looking at the picture, looking at the graph. And the equation that we are going to use here is the standard quadratic equation in factored form. Okay, so we know that factored form is y is equal to a times x minus r and x minus s, where r and s are the factors. Right away, looking at the graph, we can see those factors. Here's s, and here is r. So r would be a -1, and s would be 4. Now it doesn't matter which one of these you choose to be r or s. Okay, so let's write that part in. X minus -1 and x minus plus 4. Okay. Now, this looks pretty good. What do we know about a? Well, we do know that a is going to be a negative number, right? Because this is concave down. So a has to be negative. But we don't know specifically what a is. So what we're going to do is pick any other spot on the graph. You can see that in this equation we have variables x and y and a. A is what we want to find. X and y we can replace with numbers. Let's pick any other point on the graph, and this is the easiest point to see, that y-intercept. It's going to happen, or the coordinates there are at 0, 12. Okay, now I know an x and a y. So let's plug these in. y, let's use, is 12 equals a, and x in this case is 0. I'm going to write plus 1. We know negative and negative turns out to positive. And then the x is 0 and minus 4. Okay, now we can solve this. So 12 equals, now this is 1 multiplied by negative 4. So we have negative 4a. Usually we write the coefficient before the variable letter. So I've kind of flipped the negative 4 to the left side of the a, which is still fine for multiplication. Okay, solving for a here, the negative 4 is being multiplied by a, so we divide by negative 4 on both sides. And then 12 divided by negative 4 gives us a negative 3 equals a. Okay, now we know everything. We can write our final answer. We've got factored form of y is equal to negative 3, that's the a, x plus 1, and x minus 4. Basically, that last part I just copied from here. And that is the equation in factored form. Now, it might ask you to write the function in standard form. I'm looking back up, and it does say it wants you to leave it in standard form. Remember what standard form looks like? Yeah, so there's a little bit of multiplying left here. Let's multiply this through. So, y is equal to, and I'm going to distribute the 3 through the first factor, negative 3x minus 3, and I'm multiplying that by the second factor. Now I'm going to do FOIL, okay? So first outsides, insides, last multiplication. So y is equal to negative 3x squared plus 12x minus 3x plus 12. And if I group the like terms, these are the two terms that are like. They both have an x. Then I will result with plus 9x plus 12. There we go. Here is our answer in standard form. So again, factored form was there, and here's standard form. Okay, flipping the page. Here's another question. It's asking you to write this equation in factored form. The only difference from the previous question, which we'll just talk about, I'm not going to do the whole thing. You see there's only one factor here, meaning that r and s both equal negative 1. Okay? Alright, you'll notice the key ideas listed here. That is given right from your textbook. It's a great place to look for just a summary of what we learned. And then you can proceed to your assignment, which is here. There we go. Okay, ask questions please as you go through it.